Simulation has value on its own as a point solution. However, simulation on its own is not enough. To see why, let's look at the traditional CAE process using a point solution for performance simulation. First, we need to find the data to analyze and make sure we have the correct version. Geometry repair sometimes needs to be done in an entirely separate application from meshing, which further slows down the overall process. Simcenter 3D accelerates the process of innovation because it's fully integrated in a digital thread. Since it is associative to the design, it can easily stay in sync with the design changes. Here we can see an example of how the analysis model is associated to the base geometry. When a design changes, the analyst is immediately notified through the integrated simulation data management system. Then the analyst has the option to update the analysis model. All geometry abstractions and edits like mid-surface operations will update to the new geometry. The associated mesh and boundary conditions will also update. This helps development teams get feedback on how geometry changes will impact product performance much more rapidly. So comparing Simcenter 3D to traditional CAE, we get a faster initial iteration because of the integrated geometry repair, and integrated data management system. So any updates occur quickly, easily, and robustly. How do you know you're working with the right model and right version? Have you ever wasted time analyzing the wrong data? Integrated data management is critical to going faster and avoiding wasting time analyzing the wrong data. For the demonstration today, we'll be analyzing a landing gear assembly for multiple load cases. Here we have a landing gear assembly, and we've already created a structural simulation model of the landing gear assembly, where we have some components represented as beams and others as solid elements. Here we can easily swap out a beam representation for the lower drag brace with a solid element representation. And what you'll notice is the connections are maintained when swapping out the representation from a beam to a solid element. Now that we've swapped that out, to run the simulation, we first need to make sure we have no conflicts across component finite element models. So we'll go ahead and resolve those. And then we can run our solution. And here I'll pause the video while it's running. You can see it's only taken about 30 seconds to run. And then we can view the results. So here you can see the results for the 5 subcases. Here we'll take a look at our stress results on just the lower drag brace. We can isolate just that component, and we can step through the various load cases. If we're interested in the joint loads, the axial joint loads, we've got a probe that is set up to extract those. So here we can see the axial joint loads for each of the subcases. Now, we've learned through Simcenter that there is a problem with the lower drag brace. Here we can see we've received an email through Simcenter saying that there's an issue with an interference with the lower drag brace and the trunnion. Now, to see the correct version of the model that we need to modify, that's attached to the Simcenter email. So we are assured of opening up and working with the correct model. So here we'll go ahead and make that change to the lower drag brace and make it shorter. And since our simulation models are associatively linked to our CAD model, all we need to do is update our simulation. So here we'll go ahead and say update our component finite element models. And we'll see the upper drag brace get longer and its mesh update. And the lower drag brace get shorter and its mesh update. And lastly, we can update the connections. So now that we have our finite element models updated, we'll go ahead and resolve any node and element conflicts between the various component finite element models, and we're ready to solve. So that we can maintain the original results that we had from our longer lower drag brace, we'll go ahead and clone the solution, and we'll call it 101A, and then we'll go ahead and solve. And here I'll pause the video again. We can see in just another 30 seconds or so we've got updated results. The first results that we'll take a look at are from our probes that show our axial load through the joint. Here we can see how those loads have changed as a result of changing our lower drag brace. And then we can also view the stress results. And we'll take a look at those top and bottom. Here we'll open up our original results. We'll have those in our top view. And our shorter drag brace, we'll put those results in the lower view. Here we can synchronize the views. So when we zoom or pan, we can see both models rotating, zooming, and panning. Here we can also step through the various subcases. Simcenter 3D is more than just an analyst tool to evaluate product performance. It's one step in the digital thread that enables you to make better products faster.